time to learn. This is question 3 from the packet of differential equation FRQs I gave you. All right. This one was an easy one, I hope. Yeah. Some of the other ones were a little more difficult, I think. All right. First thing you have to do is sketch a slope field. So if we're going to sketch the slope field for y squared of x minus 1, first thing we note that is whenever y is 0, the slope should be 0. So
0.
Yeah, here's a place where y is 0. Perfect. Yeah. All right. Now, 2 places where y is 0. What about when we're at the point 0, 1? What did you get when you plugged in 0, 1?
-1.
-1. What about when you plugged in 0, 2?
-4.
-4. Fairly steep slope, yeah? There we go. What about when you plugged in 2, 1?
1.
1.
And then 2, 2, 4. So this is your slope field. This slope field somehow, out of the goodness and kindness of the College Board's heart, which I'm not sure if that actually exists, that's worth 1 point, and that's worth 1 point. So, and that is often how they break down the points for a slope field, is that if the slopes are 0 slopes, they give you 1 point for it. And if the slopes are all the other slopes, they give you 1 point for all the other slopes. So if you are sitting there and have no clue what to do on the AP test on your slope field, or you're like 7 seconds left and you don't have time to figure it out, just draw a bunch of horizontal lines through every point. And they'll probably give you 1 of the 2 points for it. It's at least worth a shot. Don't do that if you have time to actually do the problem. All right. Everybody good with part A? Everybody here? Class good? Good class. Zoom good?
Yeah.
Yes.
Good Zoom. That was in here yesterday that we started Zoom good Zoom class, Zoom good class, Zoom Zoom. Oh gosh. I don't know. All of this. I'm still trying to figure out and I still don't know what it means, and so now I'm not going to be able to talk. All right. Part B. Ready for part B? Yeah, okay. Part B says we've got y equals f of x is the particular solution to the differential equation, given this initial condition that f of 2 is 3. We want to write the tangent line to f of x. So if we're going to write the tangent line to f of x, we need a point and we need a slope. Well, the point is given to us, right? The point is the point 2, 3. The slope of the solution to this differential equation, right, should be directly from our derivative. So we want to figure out what is dy dx at 2, 3. And what is dy dx at 2, 3? 9. And then you should be able to write the equation of the tangent line y minus 3 equals 9 times x minus 2. Everybody good with that? Yeah. Getting that was 1 point. And then to approximate it at 2.1, we'd have y minus 3 equals 9 times 0.1. And that'd give us y equals 3.9. And I guess I should have done this in a different color because that's what I've been doing, but that was also 1 point. Sure. That's fine. Yeah. They don't care. Decimal fraction doesn't matter to them. Everybody good there? All right. If parts A and B were 4 points total, what's part C going to be? 5 points. What? What did you say?
I said 5 points.
Oh, good job. That's correct. I turn off my video. That way when I start yelling into my mask, you guys can't even tell that I'm yelling. All right. What was those are differential equations. Y squared over x minus 1. All right, dy equals y squared over x minus 1. We got an x and a y on the right-hand side. They're being multiplied or divided by each other, or in this case, divided, which means that we need to separate the variables. Separating the variables is worth 1 point. Over x minus 1. If you did that, that's 1 point. If you didn't do that, even if you tried to integrate something later on without separating them and did the integral correctly of whatever you were trying to integrate, they will give you 0 points. You must separate the variables to get any points. Everybody good with that? Okay. How do we integrate dy over y squared?
-1 over y.
Yeah, it's just y to the -2, right? So when we integrate that, we just use the power rule, -1 over y. What about what about dx over x minus 1? That's a u sub. Very simple u sub, u equals x minus 1. Du is dx. And then we just basically end up with an integral of du over u, which is natural log absolute value of u, which is x minus 1. And then we will add a plus c to that. Now, for this particular problem, you got 1 point for this integral, 1 point for this integral. Sometimes there is a point associated with just writing plus c during these differential equations. Sometimes there is not. In this case, there was not a point associated with just writing plus c. You had to actually make an attempt. You had to write the c, but then you had to make an attempt to find the c by plugging in the initial condition of 2, 3. So if you plugged in 2, 3 and got -1/3 equals natural log of 1 plus c, or a constant of -1/3, because natural log of 1 is 0, that was a 4th point. And then you just needed to finish solving to get the 5th point. So we have -1 over y equals natural log absolute value x minus 1. What was it, -1/3? Is that what we just came up with? Yeah. And now we need to solve for y. Now, you need to take a reciprocal. True. You can get a common denominator if you want. 3 ln x minus 1 over 3 minus 1 over 3, put them together and flip it. But they'll also allow you to just do this. They're okay with this. They're all right with that. It doesn't look super nice, but whatever, they didn't seem to care. So good enough for me. And then you just multiply by a -1. You can either leave the -1 up here out in front, or you can put it at the numerator with the negative, or with the 1, make it a -1, or you can distribute it through the denominator. I believe on the scoring guidelines, they wrote it as 1/3 minus natural log absolute value x minus 1. But if you wrote negative and then this fraction that we had, that's fine. Or if you wrote -1 over, then the denominator we still have, that's fine. So anywhere you want to put the negative is fine. Everybody good with that? Yeah. Say it again, you did what? Yeah, that's fine too. Yep. Well, your final answer should have been 3 over 1 minus 3 ln x minus 1, but because of the negative. Yeah, or the -1 or -3. Yeah, that's fine. Yeah, that's totally fine. That's what I would do if I was like wanting it to look nice, but I don't know. They'll accept any of them. Other questions? Zoom good?
Yep.
Oh, do we need to write like the interval of validity or on the exam, or do they just okay with the equation?
Fine with the equation. If they specify that they want the domain for which it is valid or the interval of validity, then you need to. They last asked for that, I want to say it was the test in 19 1999, I think. They never ask for the domain or the interval of validity. I mean, not never, but it's been over 20 years. So I think you're pretty safe.
Okay, thank you.
Yep. Everybody good? Zoom good?
Yep.
Good. Zoom. Class good? Good class. All right, next one. This one was a little more difficult. I think A, B, and C were pretty straightforward, but maybe by the time you got to D, you might have struggled a little with that one. You didn't do D? D.
Yeah, I got stuck on D.
You got stuck on D. Oh no. That's all right. We'll be able to figure it out. I know how to do it. I promise. Yeah. All right. Sketch the slope field. First step. Sketch the slope field. 2x minus y. So, let's just plug in the points. 0, 1. Negative 1. 0, 2. Negative 2. 0, negative 1. Positive 1. And 1, 1. 1. And 1, 2. What is it? And 1, 2 should be 0. 2 minus 2 is 0. And then 1, negative 1, 3. So that's what you got. Once again, this was 1 point for the 0 slopes and 1 point for all the rest of the slopes. Good? All right. Part B. Find the second derivative. How do we find the second derivative of this thing? We just have to take its derivative, right? With respect to x, what's the derivative of 2x with respect to x? 2. What's the derivative of minus the y? Minus dy dx. All right. And how do we rewrite that? We'll write 2 minus the quantity 2x minus y of 2 minus 2x plus y. And that was 1 point, if you got this. And then they wanted you to determine the concavity of all of these solution curves in the second quadrant. So what do we know about in the second quadrant? We know that x is less than 0. And we know that y is greater than 0. And if x is less than 0 and y is greater than 0, we're going to have a positive 2. And then we're going to have a positive term in here, right? It's going to be minus a negative, so we'll get a plus. And then we're going to have a plus another positive. So for x less than 0 and y greater than 0, the second derivative is always greater than 0. And if the second derivative is always greater than 0, that tells you that it is concave
Up.
up. Right. Good or no? Everyone okay with that? Sure. Finding the second derivative, you just take the derivative of both terms with respect to x. So the derivative of 2x is just 2. And the derivative of minus y is minus 1 times dy dx. So you're taking the derivative of a y with respect to x. They're just saying that it's okay for you to have an x and a y in that second derivative, that you don't have to just have it in terms of one variable or the other. That's all. Yeah. The whatever the variable in the denominator is the variable with which you are taking the derivative with respect to. So that's how you know you're taking it with respect to x. And then just saying in terms of x and y just means that they don't want it to be left like this. They want it to be all in terms of x. Great. That make sense? Okay. All right. Any other questions on part B? Part B, good? Good, part B. Zoom, good?
Yes.
Yes.
Good, Zoom. Okay. Part C. We've now got a particular solution with the initial condition that f of 2 is 3. we wanted does f have a min, a max, or neither at x equals 2? Well, for part C, if we're going to have a minimum or a maximum, what do you know about the derivative then?
It's 0.
It would have to either be 0 or it could potentially be undefined. And if we look at 2x minus y, we know that's never going to be undefined for any values of x or y. So really, we're just looking to when does 2x minus y equal 0, or sorry, does 2x minus y equal 0 when x is 2 and when y is 3? So we'll say dy dx at the point 2, 3 equals, well, plug in 2 and 3, you get 1. Does it have a max? Nope. Does it have a min? Nope. So neither. Because dy dx does not equal 0, or it is not undefined. Good? Class good? No, their scoring guidelines actually didn't even write the or to undefined part. My guess is only because it was pretty clear that 2x minus y is never going to be undefined. But if if that differential equation was like, 2x over y, where it could potentially for some y values be defined, or y over 2x or something like that, where there are x values where it's undefined, you would need to specify that it's not undefined at that point. Other questions on C?
So if it was equal to 0, then that would be either a minimum or a maximum.
That's correct. You would know that it was either a minimum or a maximum. So, okay,
sorry,
so
I was just going to ask, if it was undefined, what would be the answer for that?
undefined, you wouldn't be able to determine if it was a max or a min without using a sign chart on the first derivative, which would be kind of hard to do. So you wouldn't be able to do it with a value that was undefined. That question would be impossible to answer. But what you would do if it had come out to be 0 was you could, since you can't really do a sign chart with there being an x and a y, because as x gets larger or smaller, you don't know if y is getting bigger or smaller because you don't have the actual function. So what you'd have to do is you'd have to use the second derivative. And so supposing, let's see, what was it, dy dx was 2x minus y. Suppose they then said, well, how about at the point 1, 2? Right, that was the point we had where the slope was 0. Right, so if we're talking about at the point 1, 2, well, it's a max or it's a min. Well, in order to figure out which of those it is, and so we can't do a sign chart because if I put 1 on a sign chart, I know I can plug in values larger than 1, but I don't know what y is. Right? Y is not still 2 when x is larger than 1, so I can't do that. So I have to look at the second derivative. Our second derivative, which was 2 minus 2x plus y, right, when we simplified it. You would plug in x equals 1 and y equals 2 and see that you get a positive value. And if at a critical value where the derivative is 0, you get a positive value for the second derivative, that's telling you that it's concave up. And if a function is concave up, then it's going to have a minimum. Does that make sense?
Yeah.
That's our second derivative test from a long time ago. Just thought I'd add that in. Everyone's good with that?
Yeah.
Wonderful. All right, let's actually do part D now, because part D we haven't done. So we want y equals mx plus b to be a solution to this differential equation. That seems a little weird, right? We want this linear equation to be the solution to the differential equation. So I'm going to write here, we've got y equals mx plus b is the solution to dy dx equals 2x minus y. Now, if this is the solution to this differential equation, when I take the derivative of this, it should have this slope, a slope of 2x minus y, right? What is the derivative of of mx plus b, if m and b are constants?
M.
M. So that should tell me that I can match these two things up. dy dx has to be m, but dy dx is also 2x minus y. And so I can say 2x minus y equals m. And if you made it that far, you got 1 point for writing this and 1 point for writing this. You actually got 2 pretty quick points. Then the next thing you need to do is figure out how to solve this, yeah, for m and b. No, if you just said like the derivative of this is m and you set it equal to it, that's fine. And y prime equals m, or just something to indicate you took a derivative. But yeah. All right. So next thing we need to do is we need to find a way to turn this thing that has x and y into only one variable, right? Because m and b are not variables; they're just constants, are they? Right. And they're constants that we're trying to figure out, but they're not technically variables. They are just, there is a specific number that they represent, whereas x and y could represent any infinite number of different numbers, right? So how do I get rid of the y? Right, the y should just be mx plus b. So 2x minus the quantity mx plus b equals m. And now what we're going to do is we're going to use a little trick that you, I don't know, should have seen in like an advanced integrated 3 class or an honors pre-calc class, but I don't know. I don't know if you did. I don't know what you were taught last year. So we got a rectangle there now. That's good. It's gone. 2x minus mx minus b minus m equals 0. I'm just going to get it equal to 0. And once I've done that, I should be able to, first of all, figure out how many x's are on the left-hand side by taking an x out of this equation. X times 2 minus m minus b minus m equals 0. Okay. And the trick is, we know that both sides of this equal sign need to be equivalent, don't they? I mean, they have to be. That's just how an equal sign works. So the number of x's on the left side has to equal the number of x's on the right side. True? How many x's are on the left side? No. 2 minus m. Right, there are 2 minus m x's on the left. How many x's are on the right? 0. Oh, well, there you go. And it's 2. There's a start. Okay. So now I've dealt with the x times 2 minus m with m equal to 2. So I could just go back in and plug in m equals 2 if I wanted to. If m equals 2, then this becomes 0x minus b minus 2 equals 0. And what does b equal? Should be negative 2. Okay. And if you made it that far and got those two values of those two constants, that should be the third point for part D. You write that down? I don't really get rid of it, it's still there. We just said, well, there's some number of x's over here, it's got to be equal to the number of x's over there. I mean, because it has to be, right? Both sides of the equal sign have to have the same number of x's on them. True? Yeah. On the left, there's 2 minus m, and on the right, there are 0. So 2 minus m must be the same as 0. What? Yep. Yep. And then you might think, well, that doesn't make a lot of sense, but it does. You might say the equation, why is this little rectangle still here? Oh, now it's gone. That was weird. What do we get? Y equals mx plus b with 2x minus 2, right? Well, we're saying that that is the solution to dy dx equals 2x minus y. That doesn't really seem like that makes sense, does it? Because what's dy dx? If I take the derivative of 2x minus 2, it is 2. Well, 2 is not 2x minus y, is it? That seems weird, doesn't it? That's okay. It's okay if that seems weird. 2x minus y is the same as 2x minus 2, because y is 2x minus 2. And what's 2x minus 2x minus 2? 2. Instead of a question mark, we'll put an exclamation point. Hooray! It's true. It worked. Isn't that fun? Math is cool. Math is fun. Math is exciting. My video is not on, so you can't see me staring into the Zoom camera. Zoom good?
Yep.
Good Zoom. All right. Oh my. That's a fun looking slope field, huh? For 3 minus y times cosine x. We want to sketch the curve that goes through the point 0, 1. So there's 0, 1. Something like that. Make sure it extends to the edges of the coordinate axis. Make sure it generally follows the slopes of the lines. 1 point. Any issues with that? Zoom?
No.
Wonderful. All right, part B, write the equation of the line tangent to the solution curve. You see that this comes up a lot. So writing the equation of the tangent line means we need a point, which is 0, 1. And we need a slope. And how do we get the slope?
Plug the point into the differential equation.
Plug the point into our differential equation. At 0, 1, what do we get? So we get 2. Cosine of 0 times 2. Cosine of 0 is 1. Okay. So then we will write our equation. Y equals 2x plus 1. Right? Just y equals mx plus b. Since that's a y-intercept, might as well. Okay. And that's worth a point. And then a second point if you approximated 0.2 correctly. Actually, no, yeah, just 2 points for part B. Take it back. No, just 2 points. So y equals 0.4 plus 1. And that is your third point there. 1 for A, 2 for part B, leaving you with 6 points for part C. That's pretty good, huh? Pretty good. How do we solve this differential equation?
We split the variables and you take the integral.
All right, separate the variables. Yeah, so we will dy over 3 minus y equals cosine x dx. That's 1 point. Integrate cosine x, sine x. That's the second point. Plus c. That's the third point. Integral of dy over 3 minus y requires you to use a u substitution. We're going to let u equal 3 minus y. Du will be negative dy. So we'll have a negative and a negative dy over 3 minus y. And that will give us negative integral du over u. So that's going to give us negative natural log absolute value 3 minus y. And that's the fourth point. Tori, you okay with that or no? Because if you take the derivative of 3 minus y, the derivative of 3 is 0. The derivative of negative y is negative 1 dy. Yep. Good? Everybody good there or no?
Could you leave it up for a little bit longer?
Yeah, I mean, we still got to get the last points of this problem, so we got plenty of work to do.
All right.
You know, wait for a second while you write it down, and then we'll finish it, or what do you want me to do?
You can go on.
Okay. All right. So our initial condition was that when x was 0, y was 1. Is that right? Yeah. So when x is 0, that's just a constant, and when y is 1, that's negative natural log of 2. You get a constant of negative natural log 2. So we'll have negative natural log absolute value 3 minus y equals sine x minus ln 2. Good or no? Yeah? Zoom good?
Yes.
Good zoom. Okay, so now we'll divide by the negative. And then we will do what to clear out the natural log on the left?
Exponentiate.
Exponentiate. E to that power, e to that power. That ought to give us absolute value 3 minus y equals, what does the right-hand side become? What is e to the ln 2 minus sine x?
2e to the negative sine x.
2e to the negative sine x. Exactly. You can separate those out using exponent rules, right? As e to the ln 2 times e to the negative sine x. And e to the ln 2 is just 2. We got 2e to the negative sine x. And then we'll clear up the absolute value. Either a positive or a negative. Which one do we want to choose? Positive or negative? Why positive? What was our initial condition? If x is 0, right, that gives us e to the 0, which is 1, times 2 is 2. And so I need to get 3 minus 1 equals 2. If I had had a negative out in front of there, then I get 3 minus 1 equals negative 2. That's not correct. 3 minus 1 equals positive 2. So you got to check with your initial condition when you clear out the absolute value to see if you need to put the positive or the negative version of what you got. Does that make sense, everyone? All right. And then we'll just add y to the right and then subtract the 2e to the negative sine x. So we got 3 minus 2e to the negative sine x equals y. Good or no? Everybody's all right with that? Zoom good?
Yep.
Good zoom. Last one. You guys have done all of these, right? You're not just like going through them for the first time right here. You've all done all of these, yeah? Okay. All right. dy dx equals easy y, 3x squared minus 6x. First step, write an equation of the tangent line. That should be easy. We've done a lot just like that. And you'll note that that is their go-to part, usually part B. Apparently in this case, part A, but it's their usual go-to part B is write the equation of the tangent line. Should be easy points. The point is 1, 0. So the slope at 1, 0 is 1 times, and then if we plug in 1 there, should get -3. Slope of -3. On this one, they gave you 1 point for that slope. Then they gave you 1 point for correctly writing the equation of the line. So y minus 0 equals -3 times x minus 1. Just point slope form. There's 1 point. And then approximating f of 1.2, y is -3 times 0.2, which is -0.6. 1 point for that. Good. Should be an easy 3 points. Then we're going to find a particular solution, which should be easy at least to get the first point, right? First point should go dy over e to the y equals 3x squared minus 6x d to the dx. Good? Should. Wait, what? If you did what? Yeah, you're good. As long as they see that you separated it, I mean, yeah, I would, if it were me, I would not write dy over ey equals 3x squared minus 6x dx and then make a new line for with the integral. I would do exactly what I've written here. No, this is good. Yeah, definitely. So that's 1 point. So now you're at 4 out of 9 on this problem, Marty. That's good. Then you need to integrate. The right-hand side is easy. The right-hand side is x cubed minus 3x squared plus a constant. Another point, another point. 6 out of 9 points so far on this problem were really easy. Would you agree with that? Should have got 6 out of 9 on this, pretty easy. Then to integrate dy over e to the y, some people had some difficulty with that. There are a lot of people that want to make that natural log absolute value e to the y. You cannot do that. You cannot do that because it is not dy over y. It has to be dy over y or dx over x to use that natural log, or du over u. So you could try to do a u substitution to make it du over u, but you'll find that that will not work out. What you need to do is you need to rewrite this as an integral of e to the negative y dy using that exponent rule that you can bring the denominator to the numerator by flipping the sign. And then you'll do a u sub with u equal to negative y and du equal to negative dy. Put your negative inside and outside, and you've got the integral of negative e to the u du. And what is the integral of negative e to the u du?
Negative e to the u.
Negative e to the u, and I don't know why I wrote that so far to the left. Our u was negative y, so we have negative e to the negative y. And that's another point. That's the 4th point for part C, or part B. So if you got that, you got 7 out of the 9 points, which is pretty darn good. And then you got to solve for your constant, which if you can get this far, you should be able to solve for the constant, no problem. Yeah. If x is 1, y is 0, so negative e to the 0, that's negative 1. And like we said, x is 1, so this becomes 1 minus 3 plus c. So we got negative 2 plus our constant is negative 1. Well, what does that make our constant? It should be 1. Yeah? 5th point right there. And then lastly, you will solve for y to get the 9th point. So we have negative e to the negative y equals x cubed minus 3x squared plus 1. So we'll multiply by a negative 1. I'm just going to distribute it for everything. How do you clear off the e to the negative y to make it just a negative y?
Natural log.
Natural log. So we'll get negative y equals natural log negative x cubed plus 3x squared minus 1. And then we'll multiply by another negative 1. Y equals negative natural log negative x cubed plus 3x squared minus 1. And that is the 9th point on that one. How are we feeling about these differential equation FRQ questions? Next week's quiz will be on differential equation FRQs, as well as area and volume FRQs, which I'm going to post up tomorrow for you guys to work on over the weekend. Yeah. In general, yes. Yes. Uh-oh. Probably. You want me to look at it? Everybody in Zoom, hold on 1 second. I'm gonna go solve this problem here. So a couple people in class wrote their answers as natural log of 1 over negative x cubed plus 3x squared minus 1, which is fine because this negative in the coefficient of the natural log can be pulled in as an exponent of -1. So this is natural log of this thing to the -1 power, and anything to the -1 power just means you can drop it to the denominator. So that would also be fine. So a lot of people did that. That's not a lot, but 2 people did that. Maybe others, I don't know. But at least 2. Everybody good? Zoom good?
Yes.
Yep.
Wonderful. Class good? Oh, sorry, good Zoom. Class good? Class good, good class. Okay. All right, we got about what, 15, 14, 17? I don't know, it depends on what clock I look at. We got a few minutes left. Does anybody have any questions from any of the homework problems? I'll also go over any questions from homework problems tomorrow before we take the quiz. But anybody have any questions from either of the volume solids of revolution homework assignments that I posted?
Can you do number 9, please?
Yes. Sorry, what was your question? Yeah, this week's quiz is on the solids of revolution. Just on that. Next week's quiz will be in the form of like these questions that are like the ones I've been posting of differential equations, and also for area and volume, which I will be posting tomorrow. Yeah, we'll probably do. I don't know, we'll see how many we're gonna, because next week we're gonna get through a lot of different FRQs. I might even throw a third type of FRQ in with that, like motion problems or something. But it will probably next Friday's quiz, not this Friday's quiz, but next Friday's quiz will most likely be like the entire class period on Friday. I will probably give you 4 of them and be like, all right, it'll take me 5 minutes to get started or whatever, and say, do these 4 FRQ questions and submit them before class is over. Have fun, go. I'll probably say that, have fun, go. Yeah. It's gonna be really exciting. It's gonna be great. Everyone's gonna love it. Okay, you wanted me to do question number 9, right? Question number 9 from, let's see if I can, find the assignment here. My son's tennis coach also apparently texted me for some reason. I'm not sure why. Okay, let's see here. Well, do you happen to have it there, or should I just pull it up? I'm just pulling it up. Never mind, it doesn't matter. Number 9 from the more difficult ones, I assume, because there was not a number 9 on the other one.
Yes, the more difficult one.
What was that?
I got a text message.
Texting during class.
I wasn't texting. They just decided to text me.
Sure. You probably had already texted them. All right. What are we looking at? 1 over x. There's 1 over x. That's not a very good drawing of 1 over x. With x equals 1 and x equals 2 as our bounds. There they are. And we're going to revolve it around the line x equals 3. That's the one you want, right? That's what I'm looking at here.
Yes, x equals 3.
Okay, cool. So we got this region right here. Let's say round x equals 3. So if we're going to do it around x equals 3, that means we're going to have over here some like thing that looks like this. It's sort of, I don't know what you want to call it, but it's like a I don't know, the thing. Circle it around there. It's got like these curved edges on the inside, and then it's like a really thick washer or something. Okay. Yeah, that's everything, right? Yeah. Okay. All right. So we need to figure out first off what variable we're going to do this in terms of. So what variable should we be doing this in terms of? We got to slice it horizontally, which should give us thickness of
dy.
Was it having this problem of? I kept doing that during second period with like these streaks across the page. Was it doing it earlier this period too? Yeah, it happened like 20 times during second period. Yeah, that's probably true. It's very annoying. All right, pi, and we said dy. So we're gonna have outer radius squared minus inner radius squared. Well, our outer radius extends, and we're gonna have actually we're gonna have to sort of break this down a bit because we have an issue here. If I look at the lowest part of my region, it's always the x-axis. True? Sorry, which is 0. Yeah. But the upper part, as I come up here, right, it's always going to be the same function 1 over x. But the outer radius, which is always going to be from this line right here, is not the same as this inner radius. The inner radius is sometimes this inner line, and sometimes the inner radius is the function itself. Does that make sense to everybody? If I'm looking at the outer radius and the inner radius. So from 0 to this value here, and what did I say? This was 1 and this was 2, is that right? So from from y equals 0 to y equals 1/2, my inner radius comes from this line. Right? But from y equals 1/2 to y equals 1, then my inner radius is the function 1 over x, or is related to the function 1 over x. Does that make sense to everybody? So this has to be broken down into 2 different integrals because the outer radius doesn't change, but the inner radius does. You all see that? Okay. And you remember doing some of these with area problems, yeah? Yeah. So same idea. So first, from 0 to 1/2, the outer radius is just the distance from this line to this line, which is 2. And the inner radius is from this vertical line to this vertical line, which is just 1. So that piece should be pretty easy. The second piece, plus pi times the integral from 1/2 to 1. And now my outer radius is still 2, but my inner radius is now 1. The inner radius is going from here to here. Any arbitrary place along here. Well, what's this distance here? That's x. And so it should be the full thing, 3 minus x. Does that make sense to everybody? Nodding heads here generally. At home, does that make sense?
Yes.
Okay. And then I have to turn that x into terms of y. So y equals 1 over x. So x equals 1 over y. So this will be r equals 3 minus 1 over y. Is that the part you're having an issue with setting it up, or should we continue from there?
Yeah, it was the setting up part because I did it from 0 to 1 just initially, just based on what we were doing before, and I was like, wait, this doesn't make sense.
Right.
Why is it 2? Why is it 4 minus 1 dy?
Yeah. So now hopefully it makes sense now.
Yeah.
The inner radius changes as we go. Everybody good with that? All right. Do we want to like actually do all the integrals, or do people feel okay about doing all those integrals? We want to do them? No, we don't. We feel that was a we feel okay? Yes? No? Tom, you okay? Yes, you feel okay with it. You're 100% okay with it. So don't need to do it. Okay. What? A lot of numbers. It is a lot of numbers. Yeah. All right. Who is asking that? Is that Joshua that's asking that? That guy. Okay, I think so. You're the only one that ever talks for the most part once the class starts. That's not in the class here. So you're good with that, or you want me to finish up?
I'm good.
Okay. All right. Other questions from the homework? How many of you have done the homework assignments? Some of the problems. Okay.
I have like a vague question about the quiz.
Oh, sure. I could answer that. I'll
Is
give
it
you a vague
more?
answer, but what?
Oh, okay. Is it more like complex questions? Is it more like the simpler questions?
Plan is for it to be pretty straightforward. I mean, I don't intend to give you anything like this where you have to break it up into multiple integrals.
Oh,
But I
okay.
do intend to give you integrals where you have to revolve around, something other than just the x or the y axis. We're going to revolve around x equals 3 or around y equals 2 or things like that. But what? It is possible. My guess is that they would not put this on the AP test. This is a little, okay, so I don't want to say they won't, because there are times where they put integrals on where you have to break it up into multiple different integrals to do. Usually they do not on the AP test. But sorry, did I finish answering your question? Who was that was talking the second time? I can't see.
That was me. Yeah, you answered it.
Okay, that was you. Okay.
Yeah.
Who? That was you. Your name is. I want to say it's Nolan. Is it Nolan? It is Nolan. That's
Yeah.
Because I know I can't see any of your faces right now, so.
Oh, okay. Yeah.
Even if I saw your faces, I probably wouldn't know whose face was who, but at least has the name next to the face. Okay, you're good. Okay, cool. So Melanie, to finish answering, Melanie in the class here asked about the AP test. And I hesitate to say that they wouldn't require you to do something like this. I think it's a little more difficult than you should really expect. And when we start seeing the area and volume FRQs, you'll see what I mean. That most of them are pretty straightforward. If you know what you're doing with area and volume in general. There are in the past, 10 to 15 years, a couple times where the integrals have required you to split it into two. But usually, and this is not 100% of the cases, but usually, if it's an integral that requires you to split it into two, you can use shells, which we haven't learned, but we will talk about on Monday. You can use shells usually to do it with just one integral, and that's perfectly acceptable. So, yeah, that's the best answer I can give you. I would say that, and I would not expect you to have to evaluate this like both of these integrals as part of it. They would probably just say set up an integral to find it, and then you would have to set it up. But even then, I still think it's a little more difficult than it's more difficult than what they normally put. So, I know that's kind of vague. That they probably, but I don't want to guarantee it. So, other questions? Zoom questions? Questions, Zoom questions? Okay, we have like 3 minutes, so I'm gonna say we're good and done.